This is a video walkthrough for practice 9b. In 1, we're asked to look at 4 functions that have equations in the form y equals b to the x power. And for y equals b raised to the x power, if x equals 1, y is equal to b raised to the 1 power, which is b. That can help us figure out what the values of b are. So for instance, in A, the value of b is 4 because the point 1, 4 is on the graph. Similarly, in D, the value of b is 2 because the point 1, 2 is on the graph. So this one has a value of b of 2, this one has a value of b equal to 4. Now when we look at the other two graphs, it may be difficult to quantify the value of b because b is a fractional number. So in this case, we might do better looking at x equals -1. If x is equal to -1, y is equal to b raised to the -1, which is 1 over b. So in, for instance, the second graph here, I can see that the point on the graph is -1, 3, which means that b is equal to 1/3. In the third graph, I can see that there's a point on the graph -1, 5, which means that b is equal to 1/5. So, in order from least to greatest, the values of b are 1/5, followed by 1/3, followed by 2, followed by 4. In 2 through 5, we're asked to graph each exponential function using a table of values. So, I'm going to pick an x value, and then we can, in order of operations, find the value of 2 to the x, and then add 1 to that. So if x were -2, -1, 0, 1, 2, 2 to the x is 1/4, 1/2, 1, 2, and 4. And now adding 1, we get 1 1/4, 1 1/2, 2, 3, and 5. So when x is -2, the value of y is 1 1/4. When x is -1, the value of y is 1 1/2. When x is 0, the value of y is 2. When x is 1, the value of y is 3. And when x is 2, the value of y is 5. The graph will go very slowly on the left toward a value of 1. And so I'm going to sketch in the horizontal asymptote, which is a horizontal line at y equals 1. In number 3, we can set up a similar table. We're going to start with x, and then first add 1 to it, and then raise 2 to that power to get the value of y. So, similarly, we can make our exponents, which are the values of x plus 1, equal to -2, -1, 0, 1, and 2. And then 2 raised to that power is 1/4, 1/2, 1, 2, and 4. If x plus 1 is equal to -2, we can subtract 1 to find the value of x. The same thing is true for all of the rest of the values. Just subtract 1, and now x values versus the y values are first and last columns in this table. So -3, 1/4, -2, 1/2, -1, 1, 0, 2, and 1, 4. Now we can connect and observe that the y values on the left are approaching 0, so that graph's not going to cross the x-axis. You can dash in the horizontal asymptote, but typically when it's on the coordinate axes, you don't have to. In number 4, we can set up a table of values, our values of x, and then we raise 1/3 to that power, and then subtract 4 to get the y value. So for the exponents, which are the x values, I'm going to put in -2, -1, 0, 1, and 2. And 1/3 to the -2 is +9. 1/3 to the -1 is 3. 1/3 to the 0 is 1. 1/3 to the 1 is 1/3. 1/3 to the 2 is 1/9. Now if we subtract 4 from them, we're going to get 5, -1, -3. And 1/3 minus 4 is -3 and 2/3. 1/9 minus 4 is -3 and 8/9. Now I'm going to graph each of those points. -2, 5, -1, -1, 0, -3, 1, -3 and 2/3, and 2, -3 and 8/9. So this is going to be a falling exponential function, and the values of y are going to get closer and closer to that -4. So the graph will have a horizontal asymptote at y equals -4. In number 5, we have the graph of y equals -1 times 3 to the x. So when I put my x values in, I first have to raise 3 to that number, and then multiply that result by -1 to get the y value. So for my exponents, which are the x values, I'm going to put in -2, -1, 0, 1, and 2. 3 to the -2 is 1/9. 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the 1 is 3. 3 to the 2 is 9. And now multiply each by -1, and we get the y values in the transformed function. So -2, -1/9, -1, -1/3, 0, -1, 1, -3, and 2, -9 is not going to be able to graph within this grid, but that gives us enough to see that this is a flipped exponential function. In 6 through 7, we're asked to graph the exponential function and its inverse. So I'm going to graph the function first. And for our table of values, we can have x, and 4 to the x is the y value. -2, -1, 0, 1, and 2 are the exponents. And 4 to the -2 is 1/16. To the -1 is 1/4. To the 0 is 1. To the 1 is 4. And to the 2 is 16. We're not going to be able to graph all of those, but that's going to give us a very good idea of what this looks like. -2, +1/16. Very close to y equals 0. -1, 1/4. 0, 1. 1, 4, and 2, 16 not going to be able to be graphed, but it gives us a very good idea about what this looks like. This is the graph of f of x. Now the inverse function can be graphed by taking the x and the y values and switching them. So 1/16, -2, 1/4, -1, 1, 0, 4, 1, and I'm going to skip that last point since it was ungraphable. So over 1/16 down 2, over 1/4 down 1, over 1 down 0, over 4 up 1, and that gives us an idea of what the inverse function will look like. So I'll label this one as f inverse of x. In number 7, our function g of x is 1/2 to the x. So to graph that function, we're going to graph x, 1/2 of x, 1/2 raised to the x power. Exponents are -2, -1, 0, 1, and 2. 1/2 to the -2 is +4. 1/2 to the -1 is 2. 1/2 to the 0 is 1. 1/2 to the 1 is 1/2. And 1/2 squared is 1/4. So that's our function. -2, 4 is a point on it. -1, 2 is a point on it. 0, 1, 1, 1/2, and 2, 1/4. That gives us a very good idea. This one is asymptotic toward the x-axis, but now on the right side. So this is our function, which I'm going to label g of x. let's make a table for the inverse. So the inverse can be formed by swapping the x and the y values. So 4 comma negative 2, 2 comma negative 1, 1 comma 0, a half comma 1, and 2 comma 1/4. So 4 comma negative 2, 2 comma negative 1, 1 comma 0, over 1/2 up 1, and over 1/4 up 2. This one will be asymptotic to the y-axis because it's the inverse function, so we're going to label that one g inverse of x. For number 8, 25 to the x is equal to 5. We're going to try to re-express both sides with the same base. So 25 can be re-expressed as 5 raised to the second power. So now we have 5 raised to the second power raised to the x power equals 5. When we raise a power to a power, we multiply exponents, so 5 to the 2x equals 5. And the 5 on the right side of the equation can be re-expressed as 5 to the 1. Now that both sides have the same base, we can equate the exponents, so 2x is equal to 1, and solve for x, so x is 1/2. In number 9, both 27 and 9 can be re-expressed with base 3. So 27 is 3 cubed, and 9 is 3 squared. When we raise a power to a power, we multiply the exponents, so 3 to the 3 raised to the x power is 3 to the 3 times x, and then on the right, that's 3 squared. Now that both sides are a power of 3, we can equate the exponents, and then divide, and x is equal to 2/3. In number 10, 1/8 of 32 can both be expressed as powers of 2. 1/8 is 2 raised to the negative 3rd power, and 32 is 2 raised to the 5th power. When we raise a power to a power, we multiply the exponents, so the left side is 2 to the negative 3 times x, and the right side is 2 to the 5th. Now that both sides are expressed as powers of the same base, we can equate the exponents and then divide, and so x is equal to negative 5/3. In number 11, both 4 and 8 can be re-expressed as powers of 2. 4 is 2 squared, 8 is 2 cubed. When we raise a power to a power, we multiply exponents, so the left side is 2 raised to the 2 times x, and the right 2 to the 3rd. Now that we have both sides as a power of 2, we can equate the exponents, and then divide, and x is equal to 3/2. In number 12, both sides can be re-expressed as powers of 2. 8 is 2 cubed, so now we have 2 cubed to the x power is equal to, and 16 is 2 raised to the 4th power. On the left side, we have 2 to the 3rd power raised to the x, and when we raise a power to a power, we multiply exponents, so that's 2 to the 3 times x. And on the right side, we have the root of a power, so when we re-express that using a fractional exponent, that would be 2 to the 4/3 power. Now that we have both sides as a power of 2, 3 times x is equal to 4 times 4/3, and we can clear fractions by multiplying both sides by 3, and now divide, and x is equal to 4/9. In number 13, both sides can be expressed as a power of 5. We have 5 to the 3rd power raised to the x equals 5 to the 1/2 power, because a square root can be re-expressed as a power of 5 raised to the 1/2. In other words, the denominator is the index of the root, and it's a square root. When we raise a power to a power, we multiply the exponents, and so now that we have both sides as a power of 5, we can set our exponents equal or equate them, and I'm going to multiply both sides by 2 to clear the fraction, and then divide, and x is equal to 1/6. In 14, both 16 and 64 can be re-expressed as powers of 4. You can also use powers of 2, but I'm going to do it with powers of 4. So 16 is 4 squared, 64 is 4 cubed, and so when we raise a power to our power, we multiply the exponents. When you are multiplying, don't forget to distribute times 2 to the entire quantity x minus 2. On the right side, same thing, power to a power, we multiply the exponents. Don't forget to distribute that 3 to both of the terms in 2x minus 3. Now that both sides are powers of 4, we can equate the exponents, so 2x minus 4 is equal to 6x minus 9. Subtracting 2x and adding 9, we get 5 is equal to 4x, so x is equal to 5/4. In 15, both sides can be re-expressed as powers of 2. 8 is 2 cubed, and 1/4 is 2 to the negative 2 power. When we raise a power to a power, we multiply the exponents. Don't forget to distribute 3 to both terms in x minus 1. And likewise, on the right side, don't forget to distribute the negative 2 multiplication to both terms in x plus 4. Now that both sides are powers of 2, we can just equate the exponents and then solve the resulting equation, adding 2x to both sides and adding 3 to both sides. That gives us 5x is equal to negative 5, and so x is equal to negative 1. In 16, both sides can be re-expressed as powers of 3. 9 is 3 squared, and 27 is 3 raised to the third power. On the left side, when we raise a power to a power, we multiply exponents, so the new exponent is 4x minus 6. And on the right side, the power is the numerator of the fractional exponent, and the index of the radical is the denominator. So now that we have both sides as powers of 3, we can re-express as the exponents equal to each other. So 4x minus 6 is equal to 3/4. I'm going to clear fractions by multiplying both sides by 4. So that will give us 16x minus 24 is equal to 3. And adding 24, 16 times x is equal to 27. So x is equal to 27/16. In number 7, 8 can be re-expressed as 2 cubed, and 16 can be re-expressed as 2 to the 4th power. When we raise a power to a power, we multiply the exponents, so 3 times 2x is 6x, and 4 times x minus 1 is 4x minus 4. Now that both sides are powers of 2, we can equate the exponents, and then subtract 4x from both sides, and divide by 2, which gives us x is equal to negative 2.